Hello guys, in this video we are going to discuss the solution of the problem LCS of 3 string. So let us look at the problem statement. So the problem statement says that we are given 3 strings A, B and C. The task is to find the length of the longest subsequence that is common in all 3 given strings. Okay, so the 3 strings are given, and as you can see, geeks is the string which is common in all these 3 strings, and the length of this geeks string is 5, so we are going to print 5 in this particular case. Whereas in this example there is no string or there is no sequence or subsequence which is common in these 3 strings, because of which we are going to return an empty string, and the length of an empty string is 0. Alright, so that's about the problem statement, folks. Now let us see how we will be able to solve this problem. So the objective of the question is to find the longest common subsequence in 3 strings which is given to us. So what we will do is, basically, rather than finding the LCS in 3 strings, we will study, or we will first understand how to find LCS, between 2 strings. Okay, and then once we have understood this, we will be able to scale from 2 to any string, nth string also. But let us first understand the concept of how do we find LCS between 2 strings. So let us see, we want to find the LCS between 2 string A and B, and the length of the string is M and N respectively. Okay, so here what will happen, right? It might be possible that the length of string A is equals to 0, or length of string B is equals to 0. That simply means either of the string is an empty string. Either A is an empty string or B is an empty string. In that particular case, the longest common subsequence will be the empty string itself, and the length of the empty string is 0. So that is why we are going to return 0 in that particular case. Okay, so that will be our base case. Right now what happens is, basically, I want to find the LCS between A 0 to M and B 0 to N. Right, this is what we want to find out. We want to find the LCS between these 2 strings. So what we will do is, basically, we will check if, so it might be possible that A of M is equals to B of N. It might be possible, or it might not be possible. So what will happen in the case where A of M is equals to B of N? And then we know, since one character is equal, then we know that at least the length of the LCS is 1, at least 1. Now what we need to find out is the LCS between A and B, and now we can reduce the size by 1, right? Because this comparison, we have already, the mth and the nth character we have already consumed it. So now we need to find LCS between m minus 1 and n minus 1. Please note here, A of m is equals to B of n. All right, now it might be possible that this is not equal, right? A of m is not equals to B of n. In that particular case, and this we will return it. Okay, so in that particular case, where these 2 are not equal, right, then the LCS could be, right, the LCS could be maximum of, now what could happen, it might be possible that the LCS will be from m minus 1 to n. Okay, or LCS of A, B and M and n minus 1. Okay, let me explain this, and that's the entire function, guys. So this is the brute force approach to solve this problem. If we want to find the LCS between 2 string, so first we are going to check if the base case, which is basically if either of the string is an empty string, then we are going to return 0. Otherwise, it might be possible that A of m is equals to B of n. In that particular case, we know that at least the LCS is 1. Then the LCS of the remaining characters we will try to see, or the remaining string. Otherwise, the max of LCS of A, B, M minus 1, N, and M, N minus 1. Let me explain this portion a little bit. Okay. How do we come to this? So basically what I'm trying to say is, so this is my, let us say, this is my string number A, and this contains this, right? And this is my mth location, and this is my B. This contains various strings, and this is my nth location. Okay, we know that these two are not equal, right? So now it might be possible that the LCS is from 0 to M and B to N minus 1, right? It might be possible that these two are not equal, but it could be possible that these two are equal, right? N minus 1th position. That is the condition I am trying to find out from here. Or it might be possible that it could be there in M minus 1 to B of 0 to N, right? So in one case we assume that it might be possible that these two characters are equal. Similarly, it might be possible that these two characters are equal, right? So because of which these two cases arises, and that is how, and that is what I have written it over here, and that is how we will be able to find the LCS of two strings, right? LCS between two strings. So that's the brute force solution. Now let us look at the optimal solution for this. Well, the optimal solution, in the optimal solution, as you can see, like here, we are invoking various recursive function which is of this nature, this, and this one, right? And it is very much possible that I am invoking the same recursion again and again, right? So this gives rise to a typical case of dynamic programming. So what we will do is basically we will take a table dp, okay, dp of size m plus 1 and n plus 1, all right, and dp of 0 to 0 to all the way till n, and dp of 0 all the way till m to 0, all these positions we are going to set it as 0, all right. Now what we are going to do is basically, now we want to say, let us first understand what do I mean by when I say dp of I comma j. So what dp of I comma j simply means is find out the LCS of between string a and b, and here the sizes is I and j, right? So our size, so length of a is m and length of b is n. Now dp of I comma j is a sub problem where we want to find out the longest common subsequence between 0 to I and b0 to j. So between these two I am trying to find the LCS, okay, and the result of the LCS, the result of this sub problem will be stored in the table dp of I comma j, all right. So that's the meaning of dp, a dp table, and the entries of dp of I comma j. Now let us see how we will be able to populate the entries of dp of I comma j. So in this like in the brute force solution, in this also we will be having two cases where a of I could be equals to b of j, right? It might be possible that a of I is equals to b of j. In that particular case, dp of I comma j will be equals to 1 plus, now let us solve the, so I and j are equals. Now let us solve the remaining sub problem, right? So the solution of the remaining sub problem is there in I minus 1 and j minus 1, okay. And let us say in the case these are not equal, then dp of I comma j will be equals to maximum of, and what is the maximum? dp of I to j minus 1 comma dp of I minus 1 to j. Okay, and that's it. So this is what we need to understand in order to solve the and and what do we need to return? Well, we need to return dp of m comma n. All right, this is what we need to return. Okay, so that's the dynamic programming approach, or that's the optimal way of solving this problem. Now, once we have understood this, basically to solve the problem for two strings, now let us see how we can scale this solution to solve the problem between three strings. So let us say S1, or let me use the notation X, Y, and Z strings are given, and the sizes is M, N, and O. Okay. Now, so in the two, when we were when we are trying to find this LCS between two strings, we needed a DP table of 2 dimension. Here, since we are trying to solve it between three strings, so we need a DP table of 3 dimension, and the sizes will be M plus 1, N plus 1, and O plus 1. In the same way here, DP of 0 comma 0 comma 0 to all the way till O, right? This is O, by the way, will be equals to 0. These are my base cases. dp of 0, 0 to all the way till n, and 0 will be equals to 0. Similarly, dp of 0 to all the way till m, and 0 will be equals to 0. Okay, so these are my base cases. Now let us write down the how are we going to populate dp of I, j, k. So here it might be possible that x of I is equals to y of j, and x of I is equals to z of k, right? So basically the all the three characters are equal. So if all the three characters are equal, then dp of I, j, and k will be equals to 1 plus dp of I minus 1. So the last character is equals now minus 1, and between that I need to find the LCS, j minus 1 and k minus 1. Okay, otherwise dp of I, j, k will be equals to max of, and here we have to just be little bit careful. So here, so there, if you see here we had just two, right? So I and j, because of which we had just these two. Now in this particular case there are three, so it might be possible that I, j, k minus 1, right, or dp of I, j minus 1 and k, right? Okay, and it might be possible that I minus 1, j, and k, this will give me, so one of these three will give me the max or the longest common subsequence, and that is what I am going to store it over here. Okay, so that's the discussion regarding the optimal solution. Now let us see how we are going to code it. So folks, I have already coded it, and it is pretty much the same as you have seen in the discussion. So we'll have a DP table. I'm calling it as L, and the dimension, as we have seen, is O plus 1, N plus 1, and M plus 1. And here we will iterate from I equals to 0 to M plus 1, J equals to 0 to N, and K equals to 0 to O. Okay, and I also 0 to m. And in the case for our base case, it is equals to 0. Otherwise, if they are equals, if all the three characters are equals, then LCS is equals to 1 plus for the remaining, right? Otherwise, LCS is equals to the max of 3, which is over here. And then towards the end, I am going to return the LCS of M, N, and O. So that's the code, folks. Now let us submit our solution. So our solution got accepted. That's from this video, folks. If you have any question or comment regarding this video, please feel free to drop it in the comment section and I'll try to address them. Thank you.